Okay, so thank you very much. I'm presenting the risk management discussion of the project. In fact, my intention for this talk is not to go into the technical details. I think in the session this afternoon, we will be able to go into the details through a demo, watching the particular aspects of the tool. I will use these next 30 minutes to talk a little bit about the challenges about risk management in a more generic way. So I'm representing Beawre. Basically, the mission of our company is trying to transform risks into opportunities, and I will try to discuss a little bit of how we try to do that through our software. So if I ask you what are the aspects that all these three pictures have in common, at the beginning you may think, well, these are very different as scenarios. So we're talking about self-driven smart cars, vehicles that need to talk to each other in order to avoid, for instance, accidents. We are talking about the nuclear fusion ITER project. Oh, sorry, I have to talk from the mic. Okay, now. So we are talking about the nuclear fusion project ITER in the north of Marseille, in the south of France. We are talking, for instance, about a railway accident that happened not so far away ago in Spain. And my question is, what do all these things have in common? What they have in common is that continuous risk control is essential in order to prevent accidents, to prevent problems, to prevent different incidents. Let me go a little bit more into the details. For instance, in Spain, unfortunately, we had this big accident. It was the worst railway accident since 1944. When they analyzed what was going on, what they realized is that the evidences that were indicating that there was an unacceptable risk in the railway system of Spain, in particular in that line, were clearly indicating that they should have stopped service until that was solved. Problem is that nobody was monitoring those evidences, and therefore it was an indication of lack of continuous risk control, and of course with fatal consequences. This is the Berlin airport. I don't know if you're aware of this, but the Berlin airport should have been open in 2011, so almost 10 years ago. The initial budget was less than 3 billion, not low budget, but less than 3 billion. Now it's estimated to be opening at the end of this year, and some people start saying that it's not going to happen, and it's going to happen next year. And the cost has risen to more than 7 billion. And when they tried to analyze what was going on, there were a lot of different reasons why this was happening. But one of them, including corruption and many different things, as always. But one of them, and very important, was that nobody had been seriously monitoring the quality of the documentation. And that has generated a lot of technical issues, even from an engineering point of view. So again, the lack of continuous risk management was one of the issues that generated huge problems that have impact to the whole society. ITER nuclear project, probably the most ambitious energy project in the world today. They are trying to get the first nuclear reaction based on fusion that is going to supposedly generate more energy that it will consume. This was supposed to start in 2016, an amazing project, 140 countries. In reality, it's in France, but it's not in France because the fence of the project marks the limit of the neutral zone, which is not where French laws do not apply anymore. So it's an amazing project. So imagine now all the construction companies that are building all the buildings, hosting the nuclear reactor, plus all the buildings around. They have project schedules with thousands and thousands of tasks, and each of these tasks depends on hundreds of documents that are prepared by subcontractors. If one of these documents gets late, only one, they cannot start a task. And that depends on a subcontractor going bankrupt, materials not being ready, quality assessments not being done properly, etc. So we know very well this one because, in fact, Vinci, Ferrovial, Razel, they are trusting us in order to control risk management in a continuous way. So we are basically trying to predict what's going to happen with documentation in order to avoid risks. But again, a problem where if you do not manage risk continuously, you may have a big issue. Another example, Norwegian company called Telu, IoT, and eHealth. They are basically creating a system to monitor patients remotely in smart homes. The issues they have are, as you may imagine, huge. They are developing software, but they are developing software on top of an IoT infrastructure. The IoT infrastructure is quite new in terms of what is the technology that they are using. The type of architecture they are creating has a lot of new weaknesses that are not so well understood. And of course, especially because they are dealing with very sensitive data, they need to be clearly proving that they are compliant in terms of security and in terms of privacy. Security 27001, they are the first company in Norway in this sector to be certified. And now they are trying to understand how to do that with respect to GDPR. And the big issue that they have is that proving compliance, and Samuel was before, he was making the difference between compliance and risk management, saying they are not the same thing. And I agree with Samuel, but at the same time, there is one aspect where they are the same thing, which is that sometimes to be compliant, you have to prove that you are doing continuous risk management. So basically, what we are trying to provide through our tool is compliance with the fact that you are monitoring risks continuously, which is being more predominant, more and more in different standards and best practices. So in this particular case, they are wondering themselves, okay, how do we manage to control privacy in an environment where the architecture is evolving, the software architecture is evolving super fast, the components are changing all the time, my software is being developed using agile methodologies very fast, following a DevOps cycle. So how do I manage all this? No? How do I control the risks in a way that my auditor is going to say, yes, you are being compliant with, for instance, the fact that GDPR requires you a risk-based approach. So in general, systems and processes are getting more and more complex in a way that the real bottleneck is becoming the human. The human cannot understand all the variables in an evolving system fast enough in order to make decisions, or at least it needs some help in order to pre-process this information in such a way that whenever you need to make the decision, you have the right information. As Samuel was mentioning before, there is a big gap between legal and technical requirements. If you give GDPR to an engineer, a software engineer, they say, okay, I understand the whole concept, but how does this impact my day-to-day work? How am I going to take that into consideration when I am developing my software? In the traditional risk management, you define a set of risks, you define a set of mitigation actions, and then you stamp your, you put your stamp in the risk plan. Okay, I have a risk plan, but in many cases, this risk plan is put in a drawer for 6 months, and only every 6 months you just review it. You could be surprised, and I will not say names, but in what context we see companies managing risks in huge and super complex systems with an Excel file, which is completely insufficient. But no, don't laugh. It's amazing. It's amazing. So in the traditional mechanism, you define your mitigation actions, but you typically stop there. So there are no mechanisms to really understand whether you have implemented the mitigation action efficiently and effectively, because while you have defined it, but you have not implemented it, it's like if it was not there, so your risk is clearly there. And second, when it's implemented, very rarely people or organizations control the effectiveness of those mitigation actions. And this is the whole idea of continuous risk management. And then, again, in the traditional world, an organization had a risk analyst. The risk analyst took this risk plan, and basically this person was more or less trying to control risks. This is not like that anymore. So companies are living in very complex ecosystems, especially digital companies. You are just one agent, one actor in this super complex environment where you need to be continuously collaborating with other companies, other organizations. And the big question is, how do you get all these stakeholders together in a way that they manage risk in a collaborative way? So industry is becoming more agile, even the most traditional one. So there was this McKinsey study that was analyzing the different level of digitization of different sectors. And I think there were 22 sectors, and construction was in the 21st position. So at the very end, only agriculture and hunting was below. But they are, for the last 5 years, thinking, okay, how do we embrace this industry 4.0? How do I become more smarter with my data? How do I become, how do I use artificial intelligence? And what we're basically trying to provide is a mechanism to tell organizations how to do that from a risk-driven perspective. Okay, so just to sum up, we have several issues. One is complexity, as I was commenting before, managing risk in complex systems. For instance, a complex software factory where you're creating and deploying software on top of a complex infrastructure goes beyond human skills. It's not about skills. It's not about people, about professionals not being good enough. It's about they do not having enough capacity to understand the globality of the system. Not only because the system is complex, but also because it's dynamic. By the time you have started understanding what are the vulnerabilities of your system, you are already refactoring the architecture of your software, and therefore you need to start rethinking again how to do that. Unless you have some automatization in your system, it's gonna be very difficult to catch up in time. And I'm talking about time. Time is the third ingredient, which is urgency. In many contexts, the later you detect your risks, the later you detect the evidences that help you understand that there is a problem in your system, the more money, the more resources, the more time you're wasting. And that's a reality. For instance, in the construction side, 1 week of delay is millions of euros. And that's something in software development, detecting an issue, security issue, 1 month later may make the whole difference with respect to detecting it as early as possible. So basically what we try is to help through the tools we are building in PDP4E to help organizations be smarter and taking more risk because you have better control on those risks. So we help simplifying this complexity we were talking about. So we're trying to automatize as much as possible. For instance, we'll talk about this afternoon about the automatization of vulnerability detection related to security and privacy in IT systems. We help you learn much better and faster what's going on in your system, and that's through continuous surveillance of risks in near real time, I would say. And we enable you, because typically what it happens, that's the big drama, is you have different heterogeneous sources. You need to consume data from all these heterogeneous sources at the same time, and you need to be able to cross information. And there is a theoretical trend towards platforms that try to put all together, but that doesn't match reality. In reality, your customer requires you to use a particular platform to deliver documentation. Your organization forces you to use specific tools which might not be interoperable with those ones because there is a long-term contract with a third-party provider. Your subcontractors tell you that they don't want to use certain tools because they are not interested in, and you cannot force them because you don't have power enough. So reality is much more complex than that. And heterogeneity is there by contract, and that's the message, no? Sorry, the animations are not working well here, but anyways. So our technology is AI driven. So we try to automatize, as I was telling you, as much as possible through using machine learning and trying to understand from information in the past. Continuous. We are providing mechanisms to continuously monitor risks in the system, and that's part of the novelty, for instance, for privacy. And actionable. So we are providing knowledge bases through the project. Samuel was talking about this before, where we connect Lindun. Antonio talked about Lindun, and then Samuel also did, which is providing this framework to understand what are the threats related to privacy, and very much linked to the engineering work, the day-to-day work, with general frameworks like GDPR, for instance, making the connection. And again, this afternoon we'll talk a little bit more about this. And basically, we are foreseeing that this needs to follow the typical best practices, offering this as a service, software as a service, where you have your customer, but you also may have subcontractors of your customer connecting to your platform, or even the client of your customer connected to the platform, because we try to provide a collaborative environment for different stakeholders to manage risk together. And as I was telling you, we are already using our software with different customers. So what is the value proposition? Why do we believe that this is important for industry? So first of all, to prove compliance. And again, I'm not talking about just doing the checklist of all the things you need to take into account to be compliant with a particular rule, regulation, etc. I'm talking about being able to prove that you are following continuous risk management practices. And this is something companies need to, because they have auditors saying, okay, how you can prove that you are compliant with this idea of continuous risk management. And therefore to facilitate auditing also by generating automated reports, to avoid delays and to protect budget. So at the end, all these risks typically end up having an impact on your budget or the amount of resources you have or the time it takes for you to deliver a potential product or whatever you're building. No? So how do you protect your customers and your organization in order to detect these risks based on evidences that you are continuously collecting from your system? How do you help your customer to prioritize the work based on the level of risk, which is very relevant for most customers in different sectors? How you can predict your performance, etc. Okay. So let's talk a little bit more about the challenges and how we are trying to address them in our tool. So we were talking about system complexity increasing. The reality is that there is no single way of representing your system. So your system can be represented through your architecture, but it can also be represented through the functional representation of the system, for instance, through data flow diagrams. Instead of just showing a picture, a static picture of your architecture, you are showing how data flows through the different components in your system. Your system can be, maybe it's not even an IT system, it's a process, a BPMN that explains how things evolve. And you may be interested, or maybe it's the three of them together, because you have a system with data flowing, which is part of a data, a particular business flow. How do you put all this together and manage risk there is one of the issues. Automation becomes more relevant. So you need to help users control this complexity, and that's through automating part of the process and following model-driven approaches, as Samuel was mentioning before. So we will talk more about this again this afternoon, but we will show you how our tool helps you represent the system through data flow diagrams, through the architecture, even through business processes in such a way that then you can connect these different representations to the risk analysis process. We will not show you yet, but we will talk about it this afternoon because it's not completely implemented, but we are creating mechanisms to do automated vulnerability detection on top of these different representations of the system, which we believe it's going to be very valuable for this automation process. Then systems are not static, they are changing very often, and this is where it becomes important to monitor the implementation of the mitigation actions as well as the effectiveness of these mitigation actions once they are implemented. And we will also see a little bit how we do this in our system. And then, especially if we are talking about software factories and we are talking about software development, you have a very highly digitalized environment because you are using tools for all the different steps in the DevOps cycle: planning, coding, testing, deploying, monitoring, etc. So what we are doing from our tool is trying to connect to all these tools. Right now we are already connected to Jira, and we are working to connect to Git in such a way that you can, first of all, monitor the level of implementation of your mitigation actions, because in many cases, the mitigation action will become, for instance, a feature that you need to implement in your software. And therefore, you will be able to monitor the evolution of the mitigation action there. And second, for instance, from monitoring, being able to collect metrics that help you understand what's going on in the system in real time. So this is just, for instance, an example on what some of the tools or the steps where we would like to connect our risk management tool to extract information, and then how the dashboard is in real time trying to understand what is going on in your system. Trustworthiness is a multidimensional challenge. Security, privacy, safety, they may have competing requirements. And I always present, in fact, something I learned from Antonio some months ago, which is a very good example in the automotive sector. No? In the automotive sector, in order to preserve safety, you want to share, the vehicle wants to share the position and the direction, because you need to interact with the other vehicles around you to make sure that you do not generate an accident, for instance, and you preserve safety. But at the same time, the fact that you are broadcasting your position and your direction might be okay if you just consider a vehicle like an object, but when you realize that in fact it's a proxy to the people traveling in that vehicle and its passengers, driver, etc., then it becomes a threat from a, I don't know, terrorist attack point of view, or kidnapping, or any other issue. So how do you balance these things? That's also one of the challenges that you have in this environment. We were talking about this gap between the legal and technical requirements. What we are doing from a GDPR perspective in PDP4E is trying to see how we integrate this risk-based approach that GDPR requires. And in particular, we started connecting the different categories of Linden, as they were explained before, with the data subject rights and the GDPR principles, trying to create a dashboard that allows you to understand what are the risks related to these principles and rights, but seen from risks emerging from the engineering activity in software development. And this is the value, and we believe that the first tool in the market in order to provide this connection. We are managing risk with a community, so we have different stakeholders. We are, and we will show it to you this afternoon, providing a Kanban approach in our tool. I'll show you now a screenshot. And this enables us to start thinking about risk management in supply chains with different actors, and going a little bit beyond on what we are start calling federated risk management. So for instance, right now in our tool, we have a Kanban board where you have broken into different steps the risk management process, and you can see how each of the threats evolve. Everybody can interact. They can basically manage those risks together and contribute to different steps of this risk management process together. This is just an example and the methodology that we are following, where I will not go into the details, but you can see how different actors, from the product owner to the developer, participate in each of the steps of the risk management process to enrich the quality of the process per se. And that's it. So I encourage you to come this afternoon to our session.